So first of all, we're going to look, can we factor this? Because right now, x plus 5, it could be, because negative 5 is a non-permissible value. You can write that down. We see right away that our non-permissible value, x, can't equal negative 5 for the first one. It could be that that is going to be a vertical asymptote, or it could be a hole. Whether we find it out, we're going to need to factor. Factor everything first in this unit. And sure enough, once we've factored, we realize that those are identical and that our equation just becomes y equals x minus 5. So we know that we're going to have a hole at negative 5. And if we want to find out what the y-coordinate of that hole is going to be at, we plug it back into the simplified equation. And negative 5 minus 5 is negative 10. And that's where we're going to have a hole. Yes? Yeah. Yeah. No, it's not. We can go to it. It's right. Let's see. Whoa. No, too far. Here we go. Let's see. This question right there. Look at that beautiful line. So this question right here, is this going to be a hole or an asymptote? Well, can you see that it could simplify away? Okay? And if I cancel one of these out with this, my equation would just become x minus 3, x plus 1. So because it simplifies away, there's going to be a hole when you plug in 3. But now that it's simplified, I could plug in 3, and when I plug in 3, I get 0. So there's going to be a hole at 3, 0. When it's simplified, what kind of graph is this? Quadratic, so it's going to be a parabola. It's in factored form, so you know that there's going to be an x-intercept at 3 and negative 1. This one at 3, though, we know is going to be our hole. So our final graph would look like a parabola with a hole in it. So you can graph whatever you're left with based on what you know how to graph from before. And because it canceled out, you know that it has a hole. That's very similar to the question that we're doing right now. It simplifies, what are we left with? We're left with a line. We know that our y-intercept of our line is at 0, negative 5. And we know that way down here at negative 5, negative 10, we would have a hole. So that's how you would graph that function. For part B, again, we're going to factor out the top. It has a common factor of 2. Leaves us with x plus 1 over x minus 2. So for this one, what we know is that the non-permissible value that x can equal 2 is going to be a vertical asymptote. So when we go to graph it, x equals 2 is our equation of our asymptote. Now that's something to be careful with. When you write non-permissible values, you use can't equal with a little line through it. When you write your equation of your asymptote is an equation. An equation has an equal sign. So be careful, because some people like to put the x can equal 2 with the equation here, and that would be a half-mark deduction, because it is an equation, so it should have x equals 2. Now to graph the rest of this one, this is the type 2 one, where you have the same degree on the top and the bottom. If we thought as x gets to a really, really big number, this is going to have a vertical asymptote at y equals 4. So we know what our two asymptotes are. Now if we wanted to see what this equation actually looked like, we know that our graph is going to approach our asymptotes. If I find a value, like if I plug 0 into my original equation, just a table of values. And this is a unit where using a table of values can be very helpful. I plug in 0 for x, I'm going to get negative 1. If I plug in another value, if I plug in 1 for x, on the top I'm going to get 4 times 1 plus 2 is 6. 1 minus 2 is negative 1. So I'm going to get 1, negative 6. And this section, because there's an asymptote there, it's approaching it there, and it's going to approach it that way. If I wanted to draw the rest of my graph, I need to pick a value bigger than 2. Say pick a value of x equals 3. I could plug that in. 4 times 3 plus 2 would be 14. 3 minus 2 is 1. I'd have the point way up here at 3 comma 14. And because there's asymptotes, I know that it's going to have this general shape. So I got a point in each section, and my sections are separated by my vertical asymptote. I need to find some points when x is less than 2, and some points when x was bigger than 2. And I just used a table of values to find those. Because I had my asymptotes already, I could draw the shape of my graph. Okay, the questions you can practice for this one. Number 5.